Hey guys, been a while since I posted a video. I'm working on something that's taking quite a bit longer than expected. So I thought I'd share a talk that I gave at my company. The talk is about some quirks that I recently learned about the Python programming language. We have these kind of talks every Friday, so if you want to join, you can contact the company itself. I'll post a link down below. And I already mentioned this in the talk, but basically everything I learned was from a YouTube channel called mCoding. And the demos I show in the talk are a complete copy of some of his videos. I'll also post the link of his channel down below. Now, I hope you enjoy the talk.
So, yeah, as you might know, and if you don't, Python is like the best language ever, at least when it isn't. So today I'm going to show you a couple tips and tricks to make your Python maybe go faster, and also some quirks that are really weird in how the internals of Python work. So I got a couple demos prepared. So these are the topics. So there's the comma equals operator. Probably never used that. Single most useful decorator in Python. So I actually never use decorators, but there's a fun one. Empty truth in Python. So yeah, what could that be? How to loop efficiently in Python. So loops, very basic stuff, but actually can be interesting. Yeah, how Python looks at variables, and I'm not sure if you can actually go through all of them. Like the last one is actually the longest, like let it be there. So the Python's sharpest corner, the weirdness of the plus equals operator. And basically, like I've been coding Python for a long time, and I knew nothing about any of these, and I found them all out from this YouTube channel called mCoding. This guy, like James Murphy, I think is his name, he does a lot of videos on Python, I think some C++ stuff, and mathematics. Yeah, if you want to check it out, it's this mCoding. Okay, without further ado, let's start with the examples. So the first one I want to show you is quite short. And this presentation is going to be like quite interactive, so feel free to just turn on your mic and speak, and maybe ask questions. Like, don't feel free to interrupt. We were going to start with the comma equals operator. Let's change to Python. If I save this will actually format it, and I don't want that, so I'll change it to text so it doesn't know what it is. So we have a very simple program. Define two variables. X is number 1, Y is array with number 2, and then I apply the comma equals operator. And what do you think the result might be? So feel free to type in the chat. I can see it. Oh, and yeah, can you see it actually? Was it too small? So yeah, maybe type in the chat, what do you think will come out of this? So is it 1, 2, is it the array with 1, is it a tuple with 1 and array 2, or is it just a syntax error? We can see a lot of twos. The array, yeah, I thought that one, 2 max, none or something. Okay, so many people said 2, which, let's check. It's 2. Okay, why is that? So if I turn on like Magic Python again, and if I save, it actually puts the comma on this side. So it's actually a trick question. It's not an operator. Exactly, it's tuple expansion, or basically, I think more intuitive is if you write it like this, and then you actually see like you retrieving the element out of you. Does this even work? No, I think not. Yeah, okay, too many values to expand. So it's actually just a trick question in Python, the comma equals operator. Supposedly this has been seen in the wild, but obviously it's much nicer if you just do this. Cool. Let's check out example number 2. We have decorators. Oh man, I didn't delete it. Whoops. So what do we have here? We have a very inefficient Fibonacci sequence implementation. So basically it just calls itself recursively until it's smaller or equal to 1, and then it returns it. And if you recursively go down that road, then it will add 1 plus 1 plus 1 until you get the result. Let's just see if this actually works. So decorator, so we got the first element, Fibonacci sequence is 1, second one, 2 is also 1. Let's do 3, should be 2, right? Nice. Okay, next one should be 5. No, it's 3. Never mind. Okay, there we go. So apparently it works. So we have this loop down here that's supposed to print the first 400 digits of the Fibonacci sequence using this function. Now, if I run this, you'll see it starts pretty quick, but then it slows down like dramatically, and every subsequent number takes, twice as long as the number before. This is obviously because of the poor and inefficient implementation. So like the n-1 does a lot of the calculation needed for the n-2, right? But it's all thrown away, and then you have to calculate this other one separately. And obviously this is very slow. And how could you accelerate this? If you could remember the result of certain inputs. Obviously you could just do it manually, like with a map lookup. Would just insert it in a map and then record the result and then check if it's already in the map. If not, you calculate it again, or please pick like the previous number. But there is this awesome little decorator that comes from a standard library. So it's the functools library, and you can import cache, and then can magically just put this here, run it, results instantly. So basically what it's doing, it just records the result of what you would put here for every number. And since it calls itself recursively, you can reach very high numbers, and then it already knows the result of the previous iteration, so it can just perform it once more. Now you might be thinking, if I put a very large number here, then the cache gets really big and the memory might explode. So there's another little decorator. This is the least recently used cache. And to this you can apply the amount of results you want to cache. And since it's recursive and you can still like get the result of 398 when you're computing 399, this is just as fast. So if you got like a pure function that or not a pure function, but a deterministic function that is computationally heavy, you can just use this and cache some results for faster performance. Let's do a quirky one next. So we have the empty truth. So the question for this video was, do I need this? I don't think so. The question on this video was, is there any object in Python that is both truthy and empty. And by truthy, I mean it goes inside this if, and empty is you can actually iterate over it, but it doesn't go inside the for loop. So you can apply for loops over it, but it doesn't actually go inside the for loop because it's empty. Do you have like any guesses of an object in Python that can like behave this way? You can say it, you can write it, I can see the chat.
You should be able to write one because you can overload those operators, right? But I don't know if there's a built-in one.
Yeah, you can overwrite basically anything, yeah. An iterator. Okay, how would the iterator look like? Or we can first start
I don't know. Just thinking maybe just map on empty array. I don't know. This was just a guess.
It was a pretty good guess actually, but let's start with simple array. So this is the truth. So it's not truthy, but it is empty. So it doesn't print something, but it also doesn't print truthy, and we want that. Can have maps, but same thing. So what had a pretty nice guess. So there is like a generator function or iterator, yeah, and you call it like this. No, wait. For in yeah. No, there we go. And this, yeah, it's truthy and it's still empty. Okay, interesting, but why should you care? Like, why would you even ever use this? It's stupid, right? So at least that's what I thought. And there's the issue is code from other people. That is not good. So if you have, for example, a library, and the library does something like this. So it expects an optional argument, which starts none. This is actually correct. The issue is here. So the idea is if you don't pass anything to it, then it has some defaults that it adds to options. And yeah, there we go. You can have defaults and by not writing it, or you can overwrite the defaults. The thing is, this check here is not correct. So it's a common mistake in Python. Like the correct way would be if options is none, and then you're actually checking for none, not if it's just falsy, right? And basically the idea is, like the author of the video that I saw wanted to actually have like empty, wanted to have final options as being empty, right? So if you actually, like if you were to call this the function, and if you call it like with what you want options to be, which is empty dictionary, I'm going to print options in the end, and we actually get the default, right? Because yeah, empty dictionary is falsy. So basically, if you can't control the library code, I mean, you can always try to add a pull request, but sometimes it's not the best option. And for this, if you actually pass in the X, then you get the generator expression that we want.
If you're writing this code, the correct way would be to write if options is none, right?
Exactly, yeah. But you can't control the library code many times, so in this case, like if you have this issue where you want to pass it and not have the defaults, but also want to have it empty, you can use this empty truthy object.
In this case, the options are immutable, so you could also use the default value inline, right? And then you wouldn't have the problem as the library author. But yeah, like maybe we should explain why there is this equals none idiom in Python. I mean, I tried in chat already. You can read there, I guess.
Why there is what? Like there is...
Why do we write options equals none instead of writing options equals dictionary option 1? Why the extra if?
Yeah, so basically, if you were, yeah, you can. This is, well...
Because
so,
that's also
yeah,
a Python
you could technically have this, but and have just options as default. But this is actually also a common Python mistake, because if you mutate it, so it's a mutable object, and if you mutate it, it's actually the second time you call lib function, then what will be here is the mutated option. Let me think. Can we just add it? Well, okay, now I have to change the code quite a bit. But yeah, basically, if you have the mutable object here and you mutate it inside the function, the second call to it would have the changes that were applied the first time to it. So yeah, that's also not a good pattern in Python. So this is actually correct way. There's just the checking part is not done correctly. Yeah, quirky things in Python. Okay, now let's check out my favorite example. I think that was pretty fun. It's how to loop faster in Python. So like, how interesting can loops be? So I have this simple example. It's and this is a very specific example. You'll see why later. So we have two functions that do essentially the same thing. They loop until they reach n. Put here a large number, 10 million, and they sum up, yeah, every number until 10 million. So the difference is here, it happens with a while loop. So we increment the total by the number itself, by the incrementer itself, and then we increment the variable. And in the for loop, we essentially do the same thing, but we use this range operator. And I'm going to use the timeit library, so to check how fast each one of the approaches is. Yeah, which one do you think will be faster? For loop or while loop?
Maybe the while loop, because it doesn't have to instantiate the range iterator and go through that.
Okay, let's check. Okay, it's not. It's actually the for loop. It's actually taking longer than in my tests, probably because I'm presenting it. But I think the ratios were similar. So this is interesting. The reason this happens is because range is actually like you should be calling range, and you because range is like implemented in C. It's a built-in function from Python. Yes, exactly. Jim is already saying it in the chat. So yeah, range is already like compiled and it is a C implementation. And yeah, that's why it's faster. Here you're using pure Python code to increment, and integers are basically also classes in Python. So actually calling internal methods from this class implementation. Just for fun, we can add this redundant code here that does nothing. And if we call this again, it will basically make the for loop just as slow as the while loop. but can we go faster? So yeah, I have a cheat sheet here. So whenever you can use built-in functions, and now you can see also why this is a very specific example of summing up the things in the array. Now, whenever you can, you should probably be using the built-in functions that Python provides, because those are implemented in C and probably faster. So let's compare the speeds with these ones. So, okay, we get like a much better result already, right? So yeah, note to self, use Python internal functions whenever you can. Can we even go faster? Now, many people probably know the NumPy library. It's pretty popular library. It has, I don't know, math things. I know it's used a lot in machine learning stuff, and everything that involves heavy mathematical computation. And here we have essentially the same thing from here, but yeah, with the NumPy calls. So let's see how much faster this can be. Okay, it's even faster than the C implementation from the internal Python library. There's one, so yeah, it's a pretty good implementation. I've heard, it's not that I've looked at it. There's only one downside compared to this one. That is that arange actually creates the whole array. And this would be then an array with 10 million elements. So this would actually consume a lot of memory, while this one is an iterator, and you could have it, well, as large as you want. Or, well, you could fit the largest number that fits in your computer, I guess. Now, even faster is, well, if you don't have to loop at all. Again, this is why I chose this example, or why this example was chosen, is there's actually a mathematical formula that sums up all the numbers until x or n. And as you can see, this is pure Python, no C code runs here. But if we test this, nothing is faster than knowing the answer beforehand. So it's just that quick. Yeah, this is it. It's the next example. Oh, we're going actually along quite fast, which is good because this one might take a while. The plus equals 1, but we still have one before, which is the variable lookup weirdness. Now, this one I liked a lot too, because it gives us good demos. So again, very simple code. We have two functions. One prints, well, x, and x is not really defined anywhere. And we have g that prints x, and we actually have x defined, but it's later in the function. So yeah, what do you think f will print? Or does it print, or does it error? It's easy enough, right? Like x is not defined. Error. Let's see what g does. So do you think this will be different or the same?
Probably different. Probably none.
You think none? Okay.
Yeah, because it kind of defines it in the scope, so it might be available already, but it doesn't have a value yet.
So it's still an error, but it actually is close to what you said. Really, it's a different error, right? And basically, local variable reference before assignment. So this is actually the first time we assign something to it, but we try to access it before. So this is an error and not none. This happens because, yeah, variable definition happens at compile time and not runtime. But yeah, it's like when I was asked this, I didn't expect it to actually be a different error. I thought, well, it's still not defined at that point, right? Okay, so let's go back and define X. No, okay. I don't think I have to ask you. This is pretty obvious. Now it's defined in the global scope. We print it in F, and there it is. What do you think will happen with G now?
Maybe this time it'll be none.
This time it will be none? Okay. Why would it be none though? It says it's 0 here, right?
Yeah, it doesn't make sense. It should still be the unbound local error, probably, if it makes sense.
Yeah.
But this is the WTF talk.
Okay, somebody's still saying it's better in JavaScript. I agree. Whatever. Python is always best. But yeah, again, it's a reference before assignment because, well, yeah. So basically Python goes from like inner scope to outer scope. So it first like checks this, compiles it. Okay, X is defined and is assigned to in the function. So it's actually a local variable, and it completely ignores this one. Now, I've run into this issue so many times. There's actually like a fix for it. If you do global X, I think it will print 0 because then it checks, okay, actually you want the global definition of it. Yeah.
But now you've reassigned the global variable value in the line below, right?
Yes, I have. And so avoid global variables is the is the take from here, I guess. Now, this is weird because it's actually like, it's not how other languages treat this thing. I wrote like somewhat the same example in Go. I've had to do a bit like of trickiness for it to be a bit weirder. But actually, I shouldn't have named it like this because now I take it all away. But so if we will go run this example, let's go. So we can see that the first print is actually prints this, but then the second print of A, like this, has not reassigned the value here, which is, well, what happened if you used the global thing in Python. Now, if we run the linter against this, it will actually tell us of a little error that we did. So we're shadowing the variable A, and the A is only in this scope, and this A is actually from the global scope. Yeah, so little quirks that are different between languages. I think C and C++ also act like this. Let's go to the final example already. Oh, going really quick on this one. Should have waited longer to let you answer stuff. This we can omit, blah, blah, blah. What is interesting here? Something later. Okay, this little demo here is the Python's sharpest corner, the plus equals operator. Now, bear with me on this one. Like, I get very confused. Reading it for myself, so I guess explaining it will also be confusing. But let's start. So we have this function here, defines a tuple, and tuples are immutable, so you can just change tuples. So yeah, this should be an obvious error, like you're trying to change the first element of the tuple and increment it. This is what I call in the main, it is. So Let's just confirm it. Plus equals WTF. Yeah. Tuple object does not support item assignment. Okay, it's immutable. Or simply assigning something would also be immutable. But you can actually...
What I would like to see, actually, can we just keep the previous example, but just change the tuple definition to contain 2 lists containing 1 and 2? So just put...
we are getting there. So basically, yeah. We have a tuple that has 2 lists. I think this is the example we were going for, right?
Yeah, I was just thinking that we could do it without modifying any of the remaining code by just changing the tuple definition to this, but I'm not entirely sure.
I mean, we can. It's just it's the same. You wanted to have lists inside of a tuple, right? So basically,
yes,
mutable objects inside of the immutable object.
Exactly.
And this is curious. So we can. So this is a list. It's another list. So it's a tuple that contains 2 lists, and it basically the pros and cons of subscribing to my YouTube channel. I adapted this. It's actually James, but I have to change it to Andre. And you can actually, you can actually still mutate the contents of the tuple. So basically, I extract the first element and I assign the plus equals operator to it, which in Python, well, actually can add or append to an array depending on what the context is. And here, as you can see, I have the tuple, and the first array now has this extra element in it. Fine. Now, let's try another syntax. This just worked, right? So why not write fewer lines? Let's have plus equals like this. I mean, if this worked, right? This should just work. Let's test it. Can't mutate a tuple, man. So yeah, this is kind of sad, I think, and pretty confusing, because I think we just did it. Why won't it work? So let's check out what actually happens. So this time we are doing the same as before. So I'm showing you the example that just failed. But we're trying to catch the error and then print out what happened, or print the result of pros and cons. So knowing that this will fail and get into the catch or into the accept part, what do you think that pros and cons will be? Will it still be like the original one, or will it be the one with the appended? Okay, people are saying it changed. Okay, yeah. I think I'm giving it away the way I'm saying it. But yeah, like it fails, but still does not fail, actually, right? Like this is pretty what the fuck moment. And
well, half of it worked.
Yeah. Exactly. So yeah, let's see why this happens. So what does the plus equals actually do, or what does it mean to plus equals? And so if you have like just an object doing plus equals to another object, what it actually does is it calls this iadd, in place add function from the class definition of it. So you can actually, like, as I said, integers are like classes in Python, and integers, like the class integer, implements this iadd function, as do many others. And you can define your own class and implement this, and then you can use the plus equals operator on that class, and it will internally actually be calling this method. And what it does is it saves the result, and then it reassigns the result to the original one. Now, if we have, let's say, a list or a tuple, it expands to this not trivial thing. So this syntax of accessing the nth element is actually calling another internal Python function, which is the getItem1. And this is where, this is the part that worked from this example below. Like, it does actually create something new. And well, since this thing was a list and it's mutable, this actually worked. And the tuple is basically just pointing at the array. So we mutated the array and it's still pointing to the same array. So that actually worked. And the second part would be unnecessary, as we did like here. And it's actually this call that fails. So if you want to assign to like x index 0, you're calling the internal function setItem. And since tuples are immutable, it will throw an error. A similar thing happens if you have like your own class and accessing a variable from it. Then instead of using getItem or setItem, what happens is you're using getAttribute, attr, and setUtter. Yeah, basically this is happening there. So let's look at something funny. So there's this bad list implementation. Basically, so why is this not a bug? Well, Python says it's a feature. The reason for this being that like simple integer addition depends on this. Basically, you have the result of two integers that are saved in some place in memory, and then that place, that result of it is then assigned back to the to the original int. I think I have the example of this here. Yeah. Okay, then let's check it out. So, but this would mean that actually the pointer to this initial integer would have changed, right? So let's just confirm that this is what happens. So basically, it's gonna execute this code now, and I'm printing out the ID of x, which is, well, the unique ID of this variable, or what it's pointing to, and then after incrementing it with the plus equals operator, we're gonna check out the index again, or the ID again, and we can see it's a different ID. So yeah, pointer to this variable actually changed, but it may also not change. So basically the same example, but now x is an array. Should I comment this out? Let's be safe. So now x is an array. Now we apply the plus equals operator again to it, appending a 1 essentially, and yeah, checking the result. So it's the same. Now in lists, this actually makes sense, right? Because you wouldn't want to copy the entire list to another position in memory just with one more element and then reassign the whole thing. I mean, eventually you probably have to do this if there's no more contiguous space in the array, like in front of the, in memory in front of the array, but usually you can just append to it. And it's still pointing to the same array. Now, and there's no problem with these two things behaving differently in Python, at least. Like the Python standard doesn't like make you behave one way, or there's no like standard way to behave according to plus equals, as long as you behave well consistently within the same object. So let me show you an example where this does not really happen. So we have this add list implementation. Show you the details later, but basically it just extends from list, and it overrides like this iadd method, and also like the simple add method. The simple add method is basically just applying the plus operator. So it overrides those both methods inside of this class, and and what we're doing here, so we're starting a empty list. Like this is the same as just having list. Or whoops, not what I wanted to do. Oh, come on. And what we're doing here, applying plus equals, right? And this is like the function that we have overwritten in this implementation. We're appending 1, 2, 3 to it, and then we are doing essentially the same thing, but in another function call. Okay, let's see what happens here. Okay, so yeah, I've added some prints there. So, well, not because I copied this code essentially, but the custom functions, so basically the functions that we overwrote, that they are printing things out. So we can see that with the plus equals, both of them were called twice, but apparently only one of them worked. So just the first one worked and not this one. Now, let's see, this is basically because it's a bad implementation of such thing, and what I was saying not to do. Basically, we're behaving differently depending on how it's called. So the add function basically is creating a new instance of the list with the result of adding the other part to itself. And the in-place add, which is called what? With the plus equals operator, is calling, well, itself with the plus. So this is actually called. So the reason is, like the reason this one works is this is still in the same scope. And the result, even though it's a new instance, it's actually being reassigned to bad. However, in this new function, it's also being reassigned, but it's actually to the local variable, and this does not change the other scope. So list itself does not behave like this. If you're just gonna use a list, it does it correctly, and the correct way to implement it would, I guess, be just not create a new instance. It should be the same. Yep. Yeah, so can do a lot of things wrong with the plus equal thing. Basically, and also this is also true for any of the other operators. So yeah, minus equals and times equals does behave similarly. Things other people would. I should have called it the naughty list. Yeah, one thing I could have done. But yeah, basically this is it. I think there were couple more examples on the YouTube channel. I didn't watch all of them, and I think some of them were a bit too quirky for me to be able to explain like correctly. But yeah, I encourage you to check it out. It's actually like, I wouldn't think that a channel that's just showing code and how code is running could be this interesting, but I actually liked it a lot and I learned a lot from it. Yeah, and that's it. And yeah, cool. We're cutting the hacker talk a bit shortly now, which is nice. Everyone can go to the weekend a bit earlier. So yeah, hope you liked the talk. You have any questions? 7 sets means no, then cool. Then I would say happy weekend, everybody. And see you next week.
See you.
Bye.
Bye.
See you.
Clap, clap, clap.
Clap, clap, clap.
Thank you.
Thanks.
Bye.
Have a nice weekend.
Have a nice